Okay, so welcome to the devlog for my new project اشراق, meaning illumination. This project draws inspiration from the Persian philosopher Shahab Suhrawardi and his work Hikmat al Eshraq, the Philosophy of Illumination. And Suhrawardi explored profound concepts of light, essence, and existence, which I've experimented with in a contemporary computational framework to develop this ontology, which I'll explain it further on in this video. I'll walk you through the initial phase of اشراق, a modular computational model designed to explore natural forms and functions. This journey combines coding, gaming, philosophy, and some illuminationist thoughts and mysticism. Okay, so let's have a look at what's already built here. So I'm just going to open the recent build of اشراق, which of course is built with Unreal Engine. So when we open it so far, we have this very simple menu system where we can, so for now we can just go to the models and I'll show you how it works. Basically what we have here is kind of like a notebook, an open notebook, and each node here is a different model. So it's kind of a model of models. And we can simply select the model that we want to look at and load it here. And you can see here each model has certain metadata, the date created, the revisions, some of them are different revisions of the same model, and yeah, some notes taken about the model. Okay, so now we can have a look at the first model to see what's inside these. Let's load it. So when we first load the model, it starts from this art strategic camera view from the top, where you can have this overall kind of perspective on everything, on the field, let's say, or the canvas. The canvas holds all these modules, as you can see here, that they're highlighted in yellow as my mouse hovers on them. And each module in اشراق has potential to have certain functions. And of course, they also have forms and geometries. So anything that is outside the boundaries of the modules are considered as a canvas, the gray area, as you can see in this level. So now if I press the F button, I can switch to field agents. Field agents are a form of modules that can be possessed by the player or the observer who is inspecting the model. Here, these red ball agents, they are basically the most primitive form of agents that you can crawl around. You can look and point at other modules with them. You can jump as much as you want. So it's just very simple and kind of primitive form. But it is good enough to let you kind of navigate the boundaries of the model. Another feature that's been built here is when I press tab, it brings up this metadata view of the model, where you can see a description or the notes that's taken about the model, a date of creation, how many modules been used. Here is around 3,000, and the title could be an author as well if there's a different author. And we can also embed different sound pieces here. So this can be also kind of like a commentary. Someone else could comment on a model and you can listen back to it as you're navigating the model itself. So the context of this model was to emphasize these agents, that you can have as many as them you want. They can be similar, but you are allowed to shift between them. So that means the user's perspective here can change based on what kind of agent they're possessing, can shift to a reader, can shift to a red ball moving or an agent walking. So this means that the agents that we put in our model can be very intentional based on the context that we want to express. Now let's move on to one of the most important aspects of Eshraaq, and that's functions. So when we press C, this is all very experimental features, of course. So basically this is our inventory of cars, or like a deck of cars, and each of these cars are like functions. And as you can see, they embed this sort of codes that the code is somewhat readable by humans, so you can understand what the function it would do. And you can aim as an agent once you select that card and inject it to the module. So now I'm injecting hover function to these modules. So hover basically kind of rotates the module around itself. So you can really spam this and kind of throw it around, see what happens. Now we can select different cars, movement that kind of wiggles the floor. And the functions in Eshraaq are kind of like the essence. And every module can inherit many different functions within themselves. So as you can see here, these are hovering, but they can also move and wiggle. So these functions can stack on top of each other to create more complex behaviors. So modules can also have initial functions embedded inside them. As you see, the floor here has already the physics card embedded. So if I add one more, it already falls apart. So here I want to demonstrate another kind of module that is very interesting. It's very dangerous and kind of divine in a way, because this hovering still around object, whatever it is, has a very interesting feature. Now we see how it works. So now I selected the null card, which basically removes the module from the word into the abyss. But if I apply that to the mirror module, it passes it through to all the modules in the word. So that's very interesting, because that module is aware of every module that is present, including itself. So it applies it to everyone. So you can do really kind of high level things with that. Okay, now let's have a look at another model, assemblies of wind catchers. So wind catchers are these very interesting structures from used in ancient Iran in mostly the desert areas like Kerman in the south. And they are structures that are built to catch the wind and bring them to the house in a very kind of ingenious way. But they're also very beautiful structures. And here they're all built of these simple modules, as you can see. And you can see on the left, though, that was the very basic form of wind catcher. And these, I want to emphasize that these are all assemblies. Assemblies means a very specific particular composition of modules put together that create an assembly. So these are all different assemblies of wind catchers, and you can see we have 2 of each assembly. I think we have here 4 different assemblies. This is a very basic one. Here we have a wind fountain, which is the 5th or 4th revision of the wind catcher assembly. A structure that can bring the wind in a more like a public space kind of structure, where imagine like a fountain that's put in a square and you can drink water from, but this is for wind, so you can just wash your face with the wind if you stand on these steps. Or the wind can be also stored in the pool. And of course, as we saw earlier, we can apply the same functions to kind of break down and mess with our assemblies as well. That here it takes them out of their assembly structure. Now we can also remove the mess we made with the null card, or make a hole in these wind catchers. So this is interesting because it also kind of inspires different assemblies altogether by simply applying these functional cards into the modules. So we have again this mirror module here that is good enough to obliterate everything. Okay, and here these are some other examples of using different functions. So here we applied a physics card to all the modules. And that's why it's really expensive, because to apply the same function to every module depends on the function itself. It creates a lot of overhead and calculations, so those have to be calculated, of course, by the computer. This one, for instance, you can see already the frame rate is super slow, and because it's a expensive function basically, and depending on how many modules you have in the model, this can go really extreme to the point that it can actually crash the model. And yeah, this one is, I think, it's more light per se, and so it wiggles all the modules, and you can see now everything is kind of shaking. And we can still apply the individual functions also through the strategic view from the top. Okay, now the third model that we want to have a look at is the mechanism of flight, which I basically made to test the flight function that I wrote a few months ago, and it became this kind of arena space where you can see this kind of shoebox houses, and then in the middle there's this field where these modular birds can fly around with the flight function. And now we can have a look closely as an agent. So the flight function now it stops every 5 seconds for a while. And here is again the metadata, and these birds are actually inspired by the ababil, or the swallow, that exemplifies the flight adaptation with a very rapid movements. There's an interesting story behind ababil,
You never get to
which
see
there's no time good to it.
all dream, do you?
And we can of course see again how these cars can these function cars can change the environment. So these shoebox houses, there are assemblies that are, as you see, repeated, and they are kind of remind me of also where I'm living in the south of Amsterdam, these social housings where they built in this very modernist style, and yeah, they all look the same. And so here we can apply this second physics card, which is the same as the normal one, but it only has an effect for half a second. So after half a second it freezes again after falling. So you can create actually this kind of strange platforms. So the mechanisms or the functions are also interesting in terms of their temporality. The same function has effect only for a certain amount of time. And again, we can apply it. To the same module a couple of times. So those functions stack, as you can see here. So one thing that is important to see here is that now the flight function is applied to the birds as an assembly, and every bird assembly in this ground is made out of 3 parts: the wing, the body, and this sphere or the stone that they're carrying. But if we apply the flight function to objects, they also start joining the flight mechanism, as you can see. So this can be applied to every module in the world that we want them to fly or join the flight. So here's the overall view of the mess we created. Now we go to the third revision of the mechanism of flight. So this is the same idea with a twist, so it's a different direction of it. So we basically applied the flight mechanism to the shoebox houses, to some of those shoebox houses as an assembly. So this creates a very interesting kind of function where you see these flying houses around the courtyard. And we can, of course, if we try, we can jump in one of these houses and try to fly alongside with them. It's a bit difficult. And you can get really squeezed in that courtyard with the houses, social housing, trying to fly. And of of course we can do some more adjustments to our social housing architecture if we want more light from the west side. And eventually there would be an implementation of saving functionality where you could save the state of your model. Okay, so for the last model, I want to show ziggurat of ore, which is a very work in process. I was interested in these structures. The ziggurats are these kind of pyramid-like structures, which is now modern-day Iraq, mostly in 2000 BCE, during the Babylonian and the Sumerian kind of dynasties. And let's have a look at it, because I tried to actually make it in the real scale, how so the dimensions are somewhat the same as it is right now. So what we see here is this third-person character, which is a template of Unreal Engine, very familiar. So it's another agent that we can of course use here. It's good for walking, and here you need to walk a lot because it's in order to elevate the ziggurat structure itself. And so here you see two pictures. On the left one is the sketch of how it would have looked like back in the time at its glory, and on the right it's the current state of it in Iraq, which was of course excavated and then somewhat reconstructed by Saddam Hussein, but the reconstruction process was unfinished. So this is what it is right now. And right now here is also, this is also unfinished of course, but I tried to use kind of the similar material for the brick walls, which is mud bricks used back in the time to construct these buildings. And from here, if you look, have a look, so these structures was kind of used as temples for each city at that time. So cities had gods, so each city had their own gods and their own ziggurats, different styles, different architectures, mostly pyramid-like. And the ziggurat of ore was one of the largest ones, of course. On top, if we go switch to our agent and the top floor, the very last, this is where people do offerings and probably statues of the gods. Or so this is quite interesting because I wanted to kind of explore how I can maybe make a representation of some of the Sumerian gods or Babylonian gods in here, and see how they can actually affect and change their impact their surroundings, and how their godly presence would be in terms of functional and computational mechanisms. And it's actually a lot of work, because to make it kind of fit exactly these outlines, there's a lot of considerations here. For instance, it's really difficult to actually make modular edges like this, because you end up having unique models for each part. So I'm still trying to figure this out. Anyways, that's about the ziggurat of ore. All right, so that was it. Thank you for joining me on this devlog introduction to اشراق. This project is a living and evolving system, of course, so stay tuned for more updates, and feel free to read through the blog, which is at اشراق.io, and I write more kind of philosophical and conceptual and sometimes design insights on the project. Some resources here, and you can look through some earlier posts, and of course you can make it night mode if you want. And yeah, I think that's it. Thank you so much, and if you have any thoughts and feedbacks, feel free to reach out. Always welcome.